In section 3, we talk about the remainder and factor theorems, and this is the P and the Q that you did in Algebra 2. Here, again, we go back to that same concept of it's not about the answer, it's about the, understanding and all that good stuff, okay? So, let's take a look here. Suppose you have a polynomial function like this, okay? If you know that f has a 0 at x equals 3, right? So this one has a 0 at x equals 3. Then we know that x minus 3 is a factor of x, of f of x. Let's talk about factors for a minute. If I have a number, 24, okay? What are the factors? So like one factor can be 6, right? Times something else. So if I know that 6 is a factor, I know that, 6 times another number will equal 24. Same situation. In here, I'm saying if f has a 0 at x equals 3, then x minus 3 is a factor of f of x, okay? So, if I have f of x, just like if 6 is a factor of 24, I know that 24 is 6 times something else. If I know that x minus 3 is a factor of f of x, then I know that f of x is equal to x minus 3 times something else. Okay? Now, in the case of numbers, 24 is equal to 6 times another number, another constant. In the case of a function, the f of x here is equal to x minus 3 times what? Is this a number or another polynomial function? Another polynomial function. It could be a linear function, x plus 2. It could be x squared plus 7x plus 3. I don't know. Okay? So, but basically that it's x plus 3 times another function q of x. Okay? So now, how do I solve here? How do I solve for that value with the 24? I would have done, so if this is x, good luck. If this is x, then x is 24 over 6. And if I'm solving for q of x, then q of x is f of x over x minus 3. Okay? So same situation. And that's what I talk about here. So we know that there has to be another function so that these two multiplied together equal to f of x. And how do I find that other function? It's f of x divided by that original factor. Okay? So, now, let's talk about long division for a minute. Do you guys remember long division with polynomial functions? Did you do it last year? Okay. So, if we're dividing, this, so like 33 divided by 6, right? 6 goes into 33 5 times. We get 30. And we get a remainder of 3, right? And how do we write that? 3/6, right? So let's talk about some terms here. This is what's being divided. It's called the dividend. The thing that's doing the dividing is this. It's called the divisor. And what's the 5? The quotient, and the 3 is the remainder. Okay, so let's talk about polynomial long division for a minute. Okay, now, before we do that, so I divided 33 by 6. I got 5 and remainder 3. So is this quotient a factor of 33? No. Why not? Because it has a remainder. So if it's a factor, what should the remainder be? Correct. Okay, so here we're going to use long division to factor f of x completely, given one of its factors. Here I have f of x, 2x minus 5 is a factor, so when I divide, my remainder should be 0. Okay, let's see. Let's divide here. So I write the polynomial function. And divided by. Okay, take account here. Look at the highest exponent, 3, and make sure that the exponents are written in decreasing order. And just make sure that you have every exponent starting from the 3 down to 0. So exponent of 3, 2, 1, 0, we're good. Here we're going to put our divisor, the factor. Okay, the process is this. You take the first term here, divided by the first term there. And I get what? 3x squared, right? I put the 3x squared here. Now, I multiply 3x squared by this entire divisor, okay? So it'll be 6x cubed minus 15x squared. Okay, what are we going to do now? Subtract, which is the same as make everything negative and then add. Okay, what is it? There's a thing. I forget. Okay, I'm going to change the signs, and now all I need to do is add. And so here I get 32x squared. Now I bring down the negative 104x. And then the whole process starts over again. It's like an algorithm. This is the best thing to write computer programs for. It's the repeating algorithm. Yeah.
Why do you change the sign?
Because you have to subtract. So instead of subtracting like 5 minus 3, I could change the sign and add them. It's the same. So I could either do 5 minus 3, right? It's 5 minus positive 3, right? Or I could do 5 plus negative 3. It's the same. That's the sort of thing we're doing. So now the algorithm starts over again. The first one over the first one. This is 16x, so I put positive 16x. Multiply it through 32x squared minus 80x. Change the signs and add. If you did it correctly, these two should always go away, right? So they go away, and now I have negative 24x plus 60. Okay, and then finally, same thing all over. Divide by 2x. This is negative 12. So now I put a negative 12 here. Multiply. When I change the signs now, I get a remainder of 0. Yay, it was a factor after all. So I can say f of x is equal to the first factor, 2x minus 5, times this second factor, which is my quotient. Okay, now, my instructions say use long division to factor completely. Okay, so let's factor some more. 2x minus 5. And then the red one, I need to factor some more. So I get 3x minus 2, x plus 6. Okay? Okay. So we've done this last year. Okay? So let's move it up a notch. Okay. Now I have x to the 3n minus, plus x to the 2n, blah, blah, blah. So let's look at the exponents now. Let's start from the right-hand side. I have 24. It's a constant. What's the exponent of the variable here? 0. then I have n, then 2n, then 3n. So it's like having exponent of 0, 1, 2, 3. Okay? Now, let's divide. We're told that that's a factor. Same instructions as before. So let's divide here. This is going to be the divisor. And then I put in x to the 3n plus x to the 2n minus 14x to the n minus 24.
Do we know if there's no remainder?
It is a factor. It's like number 1. Now it's b. Okay, so divide first terms with each other. X to the 3n over x to the n gives you what? X to the 2n goes in here. Now I'm going to multiply the entire binomial here. So x to the 2n times x to the n, x to the 3n, plus 2x to the 2n. Flip the signs. I have negative x to the 2n. Okay. Bring down the 14, negative 14x to the n. Okay. Now, divide this by x to the n. I get negative. Can you see from this? Not really. I'll take out the pages right now. Negative x to the what? N. Multiply negative x to the 2n minus 2x to the n. Flip the signs. How much do I have? Negative 12x to the n. Bring down the negative 24 and go one more time. So what factor am I going to put up here? Divide, divide, you get negative 12. So we get negative 12x to the n minus 24. And the remainder is 0. So we have to factor completely, right? So f of x is the first factor times the quotient. Okay, now I need to factor this further. Okay, remember how in the last lesson we factored in quadratic form? We had x to the 4 and then x squared. What did I say the pattern was? Is if this first term is the square of the second term, right? So here we have 2n, and here we have exponent of n. So basically, if you look at the exponents, the first exponent has to be double the second exponent. And that's how you can factor in quadratic form. So now, instead of here putting x and x, I'm going to do x to the n, x to the n. So that when you multiply them together, you get x to the 2n. Okay? So now I have minus 4 plus 3, and that's my factored form. Okay? All right. So let's go on to the next one. It just says to divide for this one. Okay? We're going to have to write a little small for this, I think. So we have 3x plus 2. Okay, now look at the exponents here. I have a 5, 4. I'm missing the 3, 2, 1, 0. You don't have to do this, but yeah, you can put a spacer for the x cubed and just do 0x cubed. So we're going to do 108x to the 5 minus 36x to the 4 plus 75x, plus 0x cubed, 75x squared, 36x, 24. All right? Okay, so let's go ahead and divide this out. So first, 108 divided by 3, 36x to the 4. Okay, I multiply. So 108 and 72. I'm going to change the signs. I get negative 36x to the 4. No, sorry. They're going to add negative 108x to the 4. Okay? Plus 0x cubed. So when I divide now, I get negative 36 this time, x cubed. Multiply negative 108x to the 4. Oh my gosh. Minus 72x cubed. Change the signs. 72x cubed. Okay? So quickly we bring down the 75x squared. When I divide, I get 24 x squared. So I get 72x cubed plus 48x squared. Change the signs. I get 27x squared. Bring down the 36x. What do I have when I divide? 9x, 27x squared, plus 18x. Change the signs. I have 18x plus 24. Finally, add 6. Now I get 18x plus 12. And what's my remainder? 12. So f of x, right? So the way I'm going to write this is my quotient plus 12 over 3x plus 2. Yeah.
When you subtracted this 75x squared from the 48x squared, from the 36x squared?
Because 7 plus 8 is 15. Right. So 48, 68, 75.
Oh, because
yeah.
You dropped, okay.
Okay. When you have ones like this, it's actually a little bit easier. Do we need to go through this one, or are you guys okay? I think we're good. Huh? For this one, you have to do long division. You can't do anything else. Mm-hmm. Yes. So
you can like factor it and then make factor dividing.
Right. Yeah, you have to do it this way. Otherwise, you would have to do synthetic division a couple times, right? It's actually easier. Like, it finishes in 2 steps when you do it that way. Okay, let's move on. And then if I have time, I can go back and do this one. Okay, now, synthetic division is a shortcut, right? We've done synthetic division before, right? It's a shortcut for dividing a polynomial by a linear factor, x minus c. So not, x squared plus something. It has to be linear. So this does explain how to do it, but let's just do one and then you'll see. Okay, so for synthetic division, we make a chart like this. And here, The good thing about this is it gets rid of all of the variables. You only deal with the coefficients. So here, this is your dividend. Look at the exponents. You have to make sure that you have all of them represented here from the highest to 0. So 5, 4, 3, 2, 1, 0, we're good. Let's just write the coefficients here. 2, -4, -3, -6, -5, -8. The number that goes outside is this divisor set equal to 0, and you solve it for x, so we get x equals 3. Okay, now the first number drops down for free. Now anything that makes its way down here gets multiplied by that 3. So I multiply this way, I get 6. I add this way, and I get 2. I multiply here, and I get -6. I add, and I get what? Oh, sorry, +6, and I get 3, because we just multiply by 3 each time. So multiply by 3, get 6, add, get 3. Then multiply by 3, get 9, add, get 3. Multiply by 3, get 9. Add makes it 4. Multiply, we get 12. You add, you get 4. Now, the reason why I do my arrows this way, you can see all the diagonal arrows are like, like X's for multiplication, and then all the vertical ones are like vertical pluses, right? So that's how you can keep that in mind. Now, the very last number here is the remainder. Okay. All right. So how do we write the quotient? The bottom numbers here represent the quotient. These are the coefficients of the quotient. So if my dividend, whatever the degree of the dividend was, when you do synthetic division, the degree goes down by 1. So if the highest exponent here was 4, if that was x to the 4, then now the leading coefficient, the leading term is going to be x to the 4. So it's like here, we have, if it was 5, if it was x to the 5, now it's going to be x to the 4. Okay? So here we get x to the 4, x cubed, and so on. So this is going to be 2x to the 4 plus 2x cubed plus 3x squared, 3x plus 4, plus the remainder over x minus 3, just like before. Okay? Now, one more terminology. This here, like the polynomial that we get after synthetic division, do you guys know what it's called? You know what that polynomial is called? That's called the depressed polynomial. Because you get it, because it literally like it depresses from the, okay. So that was that. Now, okay, so take a look at this one. We have two problems here. One is we're missing the x squared. Another problem is here the divisor has a coefficient other than 1. So what we're going to do is we're going to divide this by 4. Okay, each term by 4. And this is what students often miss. You also have to divide everything here by 4. Let's think about why. This is something divided by something else, right? This is something divided by something else. Suppose you had 12 divided by 16. Can I just divide the 16 by 4 and make it 12 over 4? No. If I divided this by 4, I also have to divide that by 4 and make it 3. Okay? So you can't just divide 1 by 4. Cool. Okay, so now my coefficients, remember I'm missing the 2 here, so I'm going to have to put a 0 there. Okay. My coefficients are going to be 48 divided by 4, 12. 28 divided by 4, 7. 68 divided by 4, 17. 0. 11 over 4. And 3 over 2. Oh my God, look at all those fractions everywhere. Okay, now, when I divide this by 4, I have x plus 1 over 4, which means x is negative 1 over 4. So I'm going to put negative 1 over 4 right there.
Oh, yes.
Yeah. So, and then everything else is the same. 12 comes down. Multiply by 1/4, negative 3. Add. Multiply by that, negative 1. Yes.
Why do you divide the other one by 4? It's like you're just solving for x.
You're not solving for x. Like ultimately, oh, this one?
Yeah, like either way.
Either way it's going to be the same. I just had to highlight a point that we have to make this a coefficient of 1 for this to work. Okay? And when you do that, you have to multiply this by 4 as well. It won't work otherwise. Okay? Negative 4. And then here I get negative 1. Nope, positive 1. What's 11 over 4 plus 1 these days? 15 over 4. Times negative 1 over 4? Negative 15 over 16. And when you add them, you get 9 over 16. Okay, here's why I have chosen this problem. So now my quotient is 12x to the what? Plus 4x cubed, 16x squared, negative 4x, plus 15 over 4, plus 9 over 16 over what? 4x plus 1. I'm sorry, it's not 4x plus 1. It's x plus 1, 4. But now look at, because we divided. But now look at what we're going to do. This is a complex fraction. And we can't leave it as a complex fraction. So what you have to do is, this is 9 over 16 times 1 over x plus 1/4. Okay? Which is 9 over 16 x plus 1/4. You distribute, so it's 9 over 16x plus 4. So really the answer is all of that business. Very quickly, this is when I need copy and paste. Okay, plus 9 over 16x plus 4. Will it make a difference points-wise on your quiz and test? Of course it will. Okay. Can I go back up or can I bring the screen back up? Okay. All right. Okay. Okay, so here's the remainder theorem. If a polynomial is divided by a term, x minus c, then the remainder is actually f of c. Okay? So what we're talking about is we can evaluate a polynomial function at x equals c. So for example, I have this polynomial function here. I can find f of negative 2, right? What would we normally do if you wanted f of negative 2? Plug it in, direct substitution, and get the answer. You could also do synthetic division, and then whatever the remainder is, that's your answer. So let's try it. Let's not take anything for granted. Let's first do what we call direct substitution.
On a test, would you just give us a function and say divide it, or would you say use synthetic or use long division?
I am very specific on the test. I say, divide using long division, divide using synthetic division. Find f of negative 2 using direct substitution, synthetic substitution. I need you to know all of the different terminologies. Huh? Yeah. So look at this one. So direct substitution is what you've always done. F of negative 2 is equal to 3 times negative 2 to the 4th minus 8 times negative 2 cubed plus 4 times negative 2 squared plus 6 times negative 2 minus 9. Okay, so that's not very, it's possible to do, but it's so much work, right? And then when you finally do it, Benny, did you already? Okay, I'll help you. It's 107.
I was almost there.
You get 107. Okay? All right, now let's do what we call synthetic substitution. Synthetic substitution, we're going to put the coefficients of the polynomial here just like before. 3, negative 8, 4, 6, 9. Here, I just put negative 2. That value is given for me, right? That's already given to me. There is no x minus that I need to solve. So don't go changing signs over there. You're given negative 2, you put negative 2. And now let's do my synthetic substitution or synthetic division.
Yes.
Sure. Okay, 3, negative 6, negative 14, 28, 32, negative 64, negative 58, 116. And when you divide, when you subtract, 107. Yes! I wish I had time to prove this. Maybe one day, if I have time. Well, a lot. Because synthetic division, we were just dividing. And we were focused on, what the quotient here. Here, like if you want the answer, you were just going to say f of negative 2 is equal to 107. You're not breaking it down into the quotient and so on and so forth. I wish I had time to prove it to you guys. Every year, I just run out of time, but hopefully we can make time. Okay, so we divided, okay, and the remainder is f of negative 2. Okay, now suppose this number, which is, you guys already know this. Suppose this number, which is now we know it's f of negative 2. Okay, suppose this was 0. What would it tell you about negative 2? Okay, x plus 2 is a factor, and if x plus 2 is a factor, negative 2 is a 0 of the equation. Okay? All right. So that's the factor theorem. It's an actual theorem, guys. It's an actual theorem. So a polynomial Where's my highlighter? A polynomial has a factor x minus c if f of c is equal to 0. So if f of c is equal to 0, then x minus c is a factor, and then x equals c is a 0 of the function. So, okay. So use the factor theorem here to determine if the binomials are factors of blah, blah, blah. So let's see. In order to see if it's a factor, we have to do synthetic division. If we get remainder 0, yes, it's a factor. So let's do it. So first, I have 1, negative 2, negative 13, negative 10. 1, oh, so what am I doing? Okay, what am I going to put here? 5. So 1 comes down, 5, 3, 15, 2, 10, 0. What do you think? Yes. Okay, so what happened here? F of x divided by x minus 5 is not 0. We divided it. Okay, it gave remainder equals 0. Therefore, x minus 5 is a factor. Now, I know you're going to ask, do we have to write all that on the test? Not necessarily. If it's asking you, is it a factor, just tell me yes, is a factor. But if I then have some other like twisted question, you should know that the reason why this is a factor is because the division gives remainder equals 0. And this could be a great multiple choice question. Okay? Okay. It could be a great multiple choice question. So why is this a factor? Because when we divided f of x by x minus 5, it gave us remainder equals 0. So I could just say, blah, blah, blah implies that, and, like these could be answer choices. Okay, but what about this one? We're going to do it with negative 2. Okay, go ahead and do this one and tell me if it works. I'll pause this. Oh, look, you guys already did it. It does work. I'm just going to write the bottom ones. Yes, it works. Okay? Fantastic. All right, we're going to put it all together. It says to solve each equation, right? So it says solve this, given that negative 1 is a 0. So let's work backwards for a minute. Okay? If negative 1 is a 0, then what do we know? That x plus 1 is a factor. Okay, so let's now divide this by negative 1. Let's do synthetic division with negative 1. We're going to divide by x plus 1. I have 15, 14, negative 3, negative 2. It does, because you need to know in the end that you need to find the 0. So in a little bit, we'll come to that. So when I do my synthetic division here, I get 15, negative 15, negative 1, 1, negative 2, 2, 0. Great, we got 0. If you didn't get 0, you would have to go back and see where you made a mistake. Okay? So now I can rewrite this equation. I've now factored this equation. One of the factors here was x plus 1. And then from here, I get the other factor, 15x squared minus x minus 2 equal to 0, because ultimately I'm working with this equation, setting it equal to 0. I need to not factor, but find the zeros. Okay, I'm going to factor this further, and it turns out it's 3x plus 1, 5x minus 2. So the zeros are negative 1, negative 1 over 3, 2/5. We talked last time about the degree telling us the maximum number of zeros, right? 3, all 3 are accounted for, we're good.
2 times? 2 times?
You mean multiplicity?
No,
What?
there's a 2 times. Isn't there like
Oh, 2 turning points? Yes, at most 2 turning points. So, okay. All right. Here, let's do another one. Now, negative 1/3 is a root. So, we're going to have negative 1/3 out here. And notice in the first problem, it said negative 1 is a 0. Now it's telling you negative 1/3 is a root. These are interchangeable, and you have to recognize that they're interchangeable. Yes?
in number 4 when we got a fraction,
Uh-huh.
it was like 3x plus 1.
Mm-hmm.
Divided by 3.
No, this has already been done for you. Yeah.
Could you do long division with 3x plus 1?
You could. I don't know why that. I mean, yeah. I wouldn't because it's a lot more work. Yeah. Okay, so 3, and then we have negative 1, 6, negative 2, negative 24, 8, 0. So I have x plus a third times 3x squared plus 6x minus 24 equal to 0. Now, I know for this particular problem, this wouldn't make a difference. But if this problem was asked a certain way, and it asked you to factor this polynomial, given that whatever is a root, okay? Then you wouldn't leave the x plus 1/3 as x plus 1/3. What you would do is you would move this up and you would write it as 3x plus 1. Okay? You wouldn't leave it as x plus 1/3. It would like if it just said to factor.
Could you also just have like that?
Okay? Huh?
You can put it as 3x plus 1, but we need to
No. Okay, and now from here we're gonna factor out of 3. Yeah.
If you were to factor out of 3, that would also be 3x plus 1. Like if you were to factor out of 3 and then multiply it into the
Right, but
how that make a difference? Because like
right, that's different. Then that's different. Now you're factoring out of 3, but then you would have a 3 outside times that. Okay? So you factor out of 3 and we get x squared plus 2x minus 8. Okay, let's factor some more. It's proper form to write that 3 on the very outside. So 3x plus 1, and then x plus 4, x minus 2. Right, but I was just showing you how to do it, but now, I mean, I'm not going to put it back now, because I already... No, in this problem it doesn't matter. But if it asked you to factor, then you had to, like...
I think the question is like, when would you not have to do it?
Okay, when you're solving, it doesn't matter how you write this, but if the question was just to factor this polynomial, and you had to give the factors, then it would be this. These would be the factors. Okay, let me solve this one and then I'll go back to that. So here, what are the zeros now? X equals negative 1/3. X equals negative 4. X equals 2. So these are the zeros. Okay, now, here's what I've been trying to say. The factors of this is my original polynomial, right? The factors of this are, what are the factors? 3, 3x plus 1, x plus 4, x minus 2. So you have to be, like, If the problem, I could give you this exact same equation, but say factor, okay? Then when you write down the factors, it has to be in this form. If you do x plus 1/3, that's not right, okay? Yeah.
So when you say solve, that means times
The zeros. If I say factor, it means do this. Okay? All right. All right, and here it says find the value of k so that the remainder is 0. If we want remainder, then we have to do synthetic division. So let's do synthetic division. 118 k 4. 3, 2, 1, 0. Okay, so 1, negative 2, 16, negative 32. Now I add, right? I'm going to get k minus 32. Multiply negative 2k plus 64. Negative 2k plus 68.
What?
You're add the 4 to the 64, not the 2. Right?
And then you have to set that.
Right, and if I want the remainder to be 0, this is my remainder. And if I want it to be 0, I set it equal to 0. So that's negative 68. And k is something, 34. No. You don't have, I mean, you can always check your work, but this was it's all polynomial functions, and the domain for those are all reals. Okay, so now this homework is due next time, Wednesday, along with your quiz on Wednesday.